Hey guys, let's talk a little bit today about slopes of a line again, but let's talk about a couple of special case. I call these special case scenarios. It kind of tricks people up a little bit. Let's look into this. So I got a coordinate plane here, and down here in the third and fourth quadrants, I got a line. I probably should have maybe highlighted this. I'm going to highlight this yellow or orange. Make it stand out a little bit. All right, so we got a line on here. Now, in my previous video, slopes of lines, or slope of a line, I went over how to find the slope always of any line, particularly on a coordinate plane, but it wouldn't even have to be on a coordinate plane. It could be just out in space somewhere. We would need to know a little information about the horizontal and vertical changes of that line, but that's why we like to have a coordinate plane laid on top of the line. So we got a little bit of information of the numbering system, right? The horizontal movement and the vertical movement. What I kind of talked about in my last video, the slope of a line video, how to always find the slope, is we want to always look at our line, and if we can, most of the time we can. Sometimes there's some weird situations where it might not work out very nice, but we could still approximate it. We want to scan through our line and find some nice points if we can. So let's look at this line here. If we look at this line, all we need is 2 points, and we can actually find a lot of nice points on this line. So nice points, I'm calling nice points a perfect intersection between a vertical and a horizontal grid line. So if we follow this line out, that's a nice point, right? Intersects a nice horizontal and vertical grid line. There's a nice point. There's a nice point. There's a nice point. Nice one, and so on, right? So we got lots of nice points here. All right, so we always want to draw a right triangle between two known points. So let's just say our two known points are here and here. Now, if we try to draw a right triangle between those 2 points, you can't really draw a right triangle because there's no vertical change between these 2 points, right? There's horizontal change between these 2 points, but there's no vertical change. So we can't really draw a right triangle like this, right, between 2 known points, or 2 known points. We could draw a right triangle like that, right? So we don't really have that option. So let's go ahead and skip that for now, and I'll come back to it. It should make sense. So slope of any line equals the change in the rise between 2 known points, and also the change in run. So rise over run. All right, so let's go figure this out for this line. So slope is going to equal rise. So let's pick our 2 known points. What is the change in rise between these 2 known points? Okay, so in other words, what's the elevation difference? And if we look at these 2 points, there is no elevation difference, right? They're on the same level. They're on the same elevation. So the rise is actually 0. Okay, and let's go look at the run. The run is the horizontal change between these 2 points. So we actually have a run, right? We could say 1, 2, a change of 2. And there we go. There's our slope, which is 0 over 2. And we can actually calculate that, right? That actually gives us a number answer, 0 divided by 2. That's actually 0. So in other words, this line has a 0 slope, and it makes sense too. I mean, if we look at this line, imagine having a road that was built like this, perfectly flat, and water rained down on this road or this line. Which way would the water run off? Well, it really wouldn't run off anywhere, right? It would just kind of displace under its own volume, and it wouldn't really run off anywhere. That's because it has a 0 slope, right? So the m of this line, actually the m of any horizontal line, is always going to be 0. And I call that a special case because we don't really have a typical rise over run answer because one of these is 0. So I call that a special case. Okay, so anytime you have a horizontal line, it doesn't matter where it's at. It could be here, it could be here, here, here. It could be way over here in the first quadrant, way down here in the fourth quadrant. It doesn't matter. If it's horizontal, you're always going to have a 0 slope. And it makes sense because rise over run is how we calculate slope. You don't have any rise, right? There's no change in vertical distance between any 2 points on your line. So your rise is always 0. All right, let's look at our other special case scenario. Let's go look at this one. Okay, so I got a new coordinate plane here. I'll go ahead and highlight this so it stands out a little bit. So here's our new line. This time we have a vertical line. Let's do the same thing. All right, this still works. Let's go pick 2 nice points on this line. We got lots of nice points, right? Maybe we pick that one and that one. This doesn't matter. Just pick 2 nice points. Try to draw a right triangle. Well, again, we can't really draw a right triangle here because in this case, we don't have any horizontal change between 2 points. We have vertical change, but we don't have any horizontal change. So let's just go ahead and keep working here. Okay, so slope equals rise over run. Let's just go ahead and look at this, all right? So our rise, so our 2 known points, hey, we have some rise, right? Rise just means vertical change. So let's go count our vertical change between these 2 known points. So 1, 2, 3. So we have a rise of 3. Okay, let's go calculate our run. So our run is our horizontal change between 2 known points on a line. And there is no horizontal change between these 2 points because there's no left or right change, right? So our run in this case is actually 0. And this is right. I mean, 3 divided by 0, this will take us to the right answer. And let's go ahead and calculate that. So if you know in math, anytime you divide by 0, I mean, we can't really calculate it, right? We don't get a numerical answer. That comes up undefined. All right, so the slope actually in this case is undefined. And that's why a vertical line always has an undefined slope, right? We say it's so steep, right? I like to tell my students that it's so steep, right? If you poured water on this line, it's actually the steepest slope you could possibly get. Water's going to run off super fast, right? You can't get any steeper. It's as steep as you can get. It's so steep you can't even put a number to it. I mean, that's kind of one way I describe it, but really it's undefined because you end up dividing by 0. There's no horizontal change, but it is the steepest line you could possibly get. So there is our 2 special case scenarios. So you can just remember this, right? Vertical lines are always undefined in their slope. M always equals undefined because it's so steep, right? There's no horizontal change. So you get a 0 as a denominator and you try to divide that out mathematically and that gives you an undefined answer. Okay, so vertical lines are always undefined and horizontal lines are always a slope of 0 because if you pour water on a horizontal line, it will not ever run off the road or run off the line, right? That's because there's no slope. The slope is 0. So there's your 2 special cases, and that's the math behind why horizontal lines and vertical lines have the answers the way they are, right? I hope that helps.